Find the volume of 6 mole of an ideal gas at 15 degrees Celsius and 101 kilopascal. So we're going to use the ideal gas law to answer this question. So PV equals nRT. We're being asked for volume, right? So maybe I'll just put a little question mark there, which leads me to think that maybe I should algebraically solve for volume and then hopefully plug in appropriate values for numbers into the expression that results. So I've divided both sides by pressure, and that isolates volume. Now, there are some potential pitfalls in doing calculations with ideal gas law, so that's the way it's worth discussing them. In terms of the numbers that are put in here, well, let's see. One of the pitfalls is about temperature. We need to be in Kelvin, so we're going to have to deal with that. Pressure, kilopascal is not the base unit. The pascal is. The pascal is really equal to a Newton per meter squared, so we're going to want to multiply that by 1,000. And we need to know what R is, the ideal gas constant. So those are some of the things we face as we go into this calculation. So I'm going to start by saying, okay, 6 mole for N. I'm just going to put mole there. That's it turns out is an okay unit. And the value for R in base units is 8.314 joules per Kelvin mole. And that's, this mole here will cancel that mole, so that's already a good thing. Hopefully we'll see how everything else turns out. For temperature, I'm going to need to take that 15 degrees Celsius, and I'm going to have to say 15 plus 273.15. And this is where maybe things get a little bit debatable. Like, what do I do with the units here? I think we've looked at that in the past, like, as you do this conversion, like, how do you do it? I'm just going to put the Kelvin on the outside here because this was all just part of figuring what the temperature in kelvins should be. That will then neatly cancel against the Kelvin that's there. And then I'm going to divide all of that by that pressure. I'm just going to turn that into 101,000 Pascal. Pascal is newtons per meter squared. A joule is a newton times a meter. We're expecting this to be volume. So if you look at the fact that the kelvins cancel, the moles cancel, and then the joule per Pascal is really where the units are going to come from, that's going to give me something in meters cubed. So let's go and put these numbers into a calculator. And my calculator says that this is 0.1423175703, but maybe I can round that off at 3 places. So 0.142, in other words, 3 significant figures seems good enough here. And that would be in meters cubed. And maybe I'm ready to check my answer. Okay, and it says 142 liters, and at first I might be shocked that I got it wrong, but units are an issue, and it's perfectly okay when you look at an answer to have it in different units, as long as you can check, well, is that really different or is it the same? Well, it turns out that there's 1,000 liters in a meter cubed, so 0.142 meter cubed is actually 142 liters, so it's correct.